Hello everyone. Welcome to the sixth installment of the network internals for the application developers and the system designs concepts. So I'm sure you're doing awesome. Here today we are going to explore the usage of the forwards and the reverse proxy, and then from there we are going to build our intuitions and concept towards the load balancers. And of course there are like various kind of load balancers, L4 L7, and among the this load balancers also different types. For example, the API gateway, ingress controller, CDN, everything we will touch upon, and we will understand that they all are banking upon the principles of reverse proxy. Okay, so without further ado, let's get started with the forward proxy. Okay, so let's take this example of Google VM, uh, any of the Google's virtual machines. Suppose one of their service like Google Drive or a Gmail service is running in one of the instances. Okay, probably they are running across many horizontally scaled instances, but just for the time consider that there is a single machine is there. Okay, that machine is there is a Google VM or a container, and then we have a forward proxy element in between. We will come to the understanding that what exactly that forward proxy does once we complete this example. And also in our use case, what it will try to do is it will try to get some sort of a update from the, either maybe from the GitHub, or maybe something from the npm.js, maybe like npm update react, something like that this guy is trying to run. And also there are some other components as well, like policy engine and audit logging. What it does is, suppose Google needs to know that what it is trying to download and whether it is really allowed or not. Suppose Google is uh, like from the Google server, somehow some malicious script got injected there, and it starts downloading something very fishy sort of a software. Then the policy engine probably will be catch that. Also in terms of the audit logging, we need to understand what are all that are whatever that are going out from the Google VM container, whatever the traffics, whatever the elements that are there, all of these things needs to be logged. So now let's explore this example with more detailing. So here we have this forward proxy layer, right? So at first, from my container, what I'm going to do is I'm going to make a HTTP request. Okay, so a HTTP request is something like npm install react. Okay, so I want to install, so I want to install React in my server machine. So what will happen is, at first it will come to the forward proxy. So forward proxies are, again, you can think like a fleet of machines. Which fleet of machines? So what this fleet of machines does is, I will just write it over here. So this fleet of machines, they controls the egress. Again, this is probably one of the new term for you. So egress means whatever the thing that are going externally, those traffic in the DevOps, SRE or the platform engineering terms is being called as egress, and whatever the coming inside, they are being called as ingress. Okay, so here we are dealing with the egress traffic. So what exactly happens there is, once this npm install react comes to this fleet of machine, what it does is it checks the security policies. So security policies are generally, like, sometimes it might be sort of a simple XML or sort of a JSON, or there may be some other kind of a configuration which controls that. So what it will do is, before sending it to anywhere else, it will just check the security policies. So from here you see what will happen is, like, it will check security policies. And what does come under the security policies? There will be things like whitelist, like domain whitelist, whether this domain is actually whitelisted or not, and also something like a content filtering. Suppose you are sending across any sensitive content or not. So this sort of things the policy engine will control. But like we are not right now going into the details of the policy engine, we will concentrate upon the forward proxy only. Okay. So what happens is after this, the policy tells back to the forward proxy, this fleet of machines, that whether to allow or block. So it is just a simple simple binary condition. It returns whether to allow or to block. And then what happens is, once it gets this response, then it logs this response into the audit logging, says that look, I am going to send across this particular npm install react with the user, that is probably the service user of the machine itself. Then alongside there will be like the destination will be maybe GitHub or the Node.js website, and also the timestamp. So this details timestamp. Okay, so these details will be logged into the audit logging system. Okay, so after this, after all of these things, then what happens is, then only this external server whatever we have, okay, forwards the request to the external server. And so here you can see, like, only till this step, it is already, the forward proxy is already taking care of four very crucial things. That is the checking of security policies, getting back the messages and taking a decision based on that, logging that request, and then at the number 4 step, what it does is it forward the request. Okay, and very important thing over here is it forward the request with the proxy IP. This is again one of the very important security consideration. Why it uses proxy IP? I will just be more clear on this. Suppose this IP is something like 171.0.0.9, okay, or 8. So this comes here, and out of this fleet of the machine, suppose this proxy is something like 10.0. Okay, this will be something else. I will rather take 170 range only, 175.1.0.12. So here what happens is, this proxy IP gets from the proxy IP, these requests are being sent. Okay, so what happens is, the advantage over here is the external server, like suppose this Node.js website sees proxy IP, okay, not client IP. So you see, this is a great security consideration that is happening, that our container or our virtual machine where we have stored our application, it is completely being abstracted by this forward proxy. Okay, so once this response comes, I will just write it here. So once this response comes from here, what happens is, like, this is again probably after this is the fifth step. So once this response comes, it just returns the response. And like after that, in case like this response has some sort of a like some sort of a filtering has to do, it cannot really do any filtering over here. Just understand that forward proxy's only intention is to forward whatever the request it gets. So from this layer, it will just forward whatever the request it gets to the Google VM container. Okay, so this will be number 5, and here it will be, this step will be number 6. Okay, so this step will be number 6. I think you got the idea over there, that why a forward proxy is important. And this is, although I took like a Google VM example to make you understand this thing, but just be very sure that there is across all the applications, okay, across all the hosted application which is are being, suppose like any application or anything across in corporate network, all of them are having forward proxy in place. Okay, so generally, like while the developers or the admins they discuss these things, they they discuss it as a egress control. So but at the end of the day, the egress control is nothing but a forward proxy itself. So now now probably you got the idea like what are the utility, like where it is being used. Now let's see what are the, let's summarize what are the uh, main functionality of this. So as you saw, like it ensures the security policies. Okay, so like blocking malicious domains, that is one of the very uh, that that is one of the very important aspect of this. And also like logging, and there is something called data exfiltration. So data exfiltration is nothing but like it is a fancy term to prevent the data leakage to a unauthorized party. For example, you are pushing some code, that code has some sort of a credentials. Okay, so this forward proxy we can equip them like in our network, from our network control only we can equip it to make sure that there are certain files, for example some of the config files which are never get even pass when the traffic is going outside. So nobody will ever be able to upload that configuration file to anywhere external. Only probably some of the authorized machines or from some of the authorized DevOps personals it will go. So those kind of things also we can maintain from the forward proxy side. Now let's discuss about reverse proxy. So reverse proxy is a very important thing in terms of the system design, and this is the basic building blocks of the load balancers. Okay, so reverse proxy on a very high level, it sits in front of the servers. So like I will write it in this way, it sits in front of the backend servers, and it's accepts the incoming requests. Okay, it accepts the incoming requests. So if I just compare with this here, it is controlling the egress or the outgress, but over here you see it is controlling the ingress. Okay, when I say incoming request, we are talking about the ingress. So now the fun part is the client is completely unaware of its presence, and it believes it is communicating directly with the original server. So suppose you from your mobile application typing some site like uh, or you are opening your Netflix app. Okay, so you get the idea that okay, my data is directly coming from the Netflix server, but maybe that is not the case. There is there might be so many in between layers, and like all of these layers and the details are being controlled by the this reverse proxy. Or like when we just go forward a little bit, we will understand the difference between the reverse proxy, CDN, API gateway, etc. So let's just take a use case and try to understand its operation in detail. So let's take this example that from your Netflix app, you are trying to reach out to and stream your video, but we will not just touch upon the streaming of the video right now. Rather, we will just see like when you are opening your Netflix app, what are the things that are happening and how does reverse proxy helps us in that. So the moment you spin up your app, like you tap onto your application and the application gets launched, you will see that your user profile is getting coming, you're getting populated, and then the recommendation service, and there are few other details also like your history, watch history. Many services will come together and give you the your collective homepage. So we will just select user profile and the recommendation service right now, and also the most important thing, that is the auth service. So let's see the life cycle of the request that happens with the Netflix app and with the reverse proxy. Okay, so the moment you launch the app, so what happens is, like the first request that goes, suppose it will be something like API slash user slash profile. Okay, now client is completely unaware of the proxy. Like here I am the user, suppose I don't even know that proxy exists, but it goes into this proxy. So what happens is, after going into the proxy, there will be this this guy, and this guy will at first not forward this thing to the user profile service on the first go. What it will do is, it will just check that whether there is any rate limiting is required or not. Suppose your application is being launched like from 10 different instances, whereas Netflix only allows 2 instances at a same moment can access it. So from the reverse proxy end only, it can rate limit, and other than rate limit also, things like the DDoS attack and everything it will check. So this happens on a very first step. Okay, so after that, what happens is, after this basic check passes, it goes to the auth service, and while going to the auth service, it tells it to validate the auth token. Okay, so once this token is being validated, so suppose this response come to the reverse proxy only that this is a valid token. So whether there are multiple requests are coming, the basic rate limiting and the validation of the token, these two things happen on a very first level. Okay, so after that, what happens is, after that, there are so many requests might be coming from here, right? App API user profile and app user recommendation services. So I will just write it here: profile recommendations. What happens is, how do I know that whether to go for the user profile and the recommendation service? This guy sitting here can take those decision. Those are being known as the routing decision based on the URL. So what it does is, it will it will take some decisions, that routing routing checkpoints, I can say routing checkpoints, and then it decide to redirect. Okay, so now we know that whether to go for the profile service, recommendation service, or like our streaming service. So at this point of time, it determines that, okay, I see that I need to go to the profile service. So what it does in the next step is, in the next step, it then forwards it to the user profile service. So just for this single application launch, you see there's so many things that are going on, and here what happens is, forward to user service, and there are some other nuances are also there, like X forwarded for headers. For example, how does user profile service know that it is coming from which client IP, in case it is necessary information for all? So the backend, like the backend sees only proxy IP as a origin, but gets real IP via the headers. So there is a headers call X forwarded for, and in the X forwarded for we can get this header. So all these things that are going on over here, you can see. After that, the user profile sends the response to this guy. Okay, now before this, okay, I just want to highlight this part. Okay, before this, at this stage, it can, or it might or might not works as a load balancer. Okay, load balancer. So this part that you see, it at that this point of time, it probably like if I configure our reverse proxy as a load balancer, what it will do is it will check whether the user profile service is really healthy or not, or if user profile service is horizontally scaled, it checks whether to forward it to the most healthy instance and the instance which can serve a request most effectively. There are various load balancer algorithm comes in play. So o- it might work as a load balancer, or what can happen is there can be a different load balancer layer. It sends the data to that load balancer, and then load balancer forwards it to this. Okay, so just understand these things. Reverse proxy has so many responsibilities. Load balancing is only among one of the responsibilities of this. So I hope this point is clear to you. So now that we are getting our response here, so other than response, suppose I see that because it is a application launch, so another request is being generated, that is another request for the recommendation is generated, recommendations. So what we are going to have over there is this recommendation, then do a get call to the this recommendation service. So yeah, this is lost in the diagram. So this is the recommendation service, and at the end here a very interesting thing happens. Like after getting all the response, aggregation happens, right? So aggregation happens, and also there can be some kind of a response policies as well, like aggregation plus response policies. Like it checks whether any malicious data or any secrets it is giving away because of the request or not. So after taking all these things into consideration, the combined response the combined response is being sent to the Netflix app of the mobile of the users mobile or the TV or web. So you can see so many steps are involved here. If I just number them for your convenience, you see at the initial level, it checks for the DDoS or any other kind of traffic manager attack. Then it validates the auth token. After validating, it controls the routing, and then it routes. And during that process, it can or cannot work as a load balancer. Then it handles the responses, and what it also does additionally is if there are multiple responses are going on, like user profile recommendations, uh, multiple calls, if it is happening, it aggregates all of them and apply its policies and sometimes filtering as well, and then sends the aggregated response back to the client. So probably you understand how critical reverse proxy is. So now let's bring both forward proxy and the reverse proxy together, and let's try to understand how both of them come into a action when a simple request that comes from the front end to the back end. So suppose you are in your corporate network machine, okay, and from your corporate network machine, like you want to access some of the website. So what will happen is, like, the first request that you will be sending, suppose you are trying to get some kind of a report. Okay, so suppose you have an application called reporting tool, like it can be API slash reporting, maybe like something like a monthly reports. Okay, so you are trying to get into this API endpoint. So what would happen is, at first it will go to the forward proxy. So what are the things that this forward proxy will do? If you remember there, like it will log the request. It will also do some kind of a inspection on like whether any malicious request is coming or not. Then also, like, it might do or might not do that whether the TLS interception is required or not. So this sort of this sort of checking from the forward proxy end will be done. Like there it will do things like security policy checking, the domain whitelisting, all the things that we discussed in our earlier step. Okay, so all these things will be done here under our log request and the inspection phase. Okay, so after this part is done, then what will happen is it will forward the request using the proxy IP to the internet. So now the request what will go, a very important aspect on this is the like request with proxy IP. So it will totally abstract away the IP of the corporate network. It will, like your corporate network machine, it will never know that who exactly is sending the request. Then this requests will come to the internet, and this internet is public. You can think as a public internet. Okay, and from the public internet, now your data or your response will be now forwarded to the reverse proxy endpoint, right? So from here it will go to the reverse proxy endpoint with proxy, not ID, it will be IP, with proxy IP. Okay, with proxy IP it will come here, and here again a lot of things will happen. For example, TLS termination, that is one of the very important aspect of the reverse proxy. So if you have not if you don't have much idea around the TLS termination, please just see the video previous to this one. We have covered TLS in very detail, and then after the TLS termination there will be things like web application firewall or WAF rules will be applied, and also it will check things like the rate limiting, and after then inspecting the route, what it will do is, suppose there is a fleet of microservices there, it will forward to the concerned microservice. Suppose there are you see there are multiple machines I have mentioned. So here what will happen is it will go to the concerned microservice. Okay, and from the concerned microservice, and from the concerned microservice then the data will come back. Okay, so now the data will come back to the reverse proxy itself, and then gradually the data will in in various level it will go back to the forward proxy. And here again this aggregations or the like the response policy application, those kind of things might happen or might not happen. So I'm not just bulking up the diagram anymore, but I think you got the idea what exactly happens, how forward proxy and reverse proxy comes together. And this is the universal architecture, we can say, that any application we see across, and any communication that we see uh, in the internet, that are happening with this model only. So before going into the load balancer, let's just revise what exactly are the importance of the reverse proxy. So reverse proxy is a very important pattern in the since the day the cloud native architecture came into play. So this is a very important cloud native pattern, and nearly every critical piece of modern infrastructure is a specialized reverse proxy. So all critical pieces of, like, this is again a very important statement, piece of modern infra in cloud is some way associated with reverse proxy. So we will see that either it is sending the data to the reverse proxy, or it can itself work as a reverse proxy, or it is getting the data from the reverse proxy. So this is a very important, that is why very important cloud native pattern. And what are the type of reverse proxy? Like load balancer is one of the type of reverse proxy. Reverse proxy has many other ways. So for example, there is something called API gateway. Now if you have worked on Azure and AWS, both have their own API gateway services. So what it does is it provide unified entry point for microservice architecture. For microservice architecture, and also like things like throttling, rate limiting, all these things I'm not writing explicitly, but if you just look up to it, what exactly is the API gateway and what are the difference between the API gateway and the load balancer, you will get a very definitive answers to that. But just understand these things. These two are the variants of reverse proxy, and there is another component of the cloud which we can say is a reverse proxy, that is called CDN. So when we are talking about the things like Akamai, the content delivery network, it cache the contents geographically close to the user for the low latency deliveries. Okay, so for this is also theoretically is kind of a kind of a reverse proxy, but many of the computer engineering purists, they keep it out of that, but it's okay, like you get the idea, right? Like whatever the content I'm delivering, that is like this layer is basically a CDN. So I am intercepting the traffic, and then again I'm reverting back some kind of a aggregated response. So that is why it can be termed as a reverse proxy. And also like things like the Ingress controller. So if you have worked on Kubernetes, in the Kubernetes cluster, you will always find there are things like Ingress controller, which is controlling the inbound traffics. So these Ingress controllers are like routing external traffic inside a cluster. Okay, so these are the type of the reverse proxy. Now let's discuss about in detail about the load balancer. So when we are talking about the load balancer, the first kind of load balancer we must be aware is it is the type of the L4. Okay, so why we call it L4? So if you see the traditional OSI layer, OSI has 7 layers, right? So the number 4 layer of the OSI is known as the transport layer, and the seventh layer is known as the application layer. So there are two basic load balancer that we have. One is the L4, the another one is the L7. So what is this L4 or the layer 4 load balancer, and based on what it controls the traffic? So of course, like routing and controlling the traffic is the primary responsibility of any load balancer, right? So what are the primary component L4 load balancer uses? That is the source IP, and again the destination IP, and then the source port, destination port, and protocol. Okay, here we have this 5 types. So protocol means like it, whether it is a TCP or UDP, right? And one of the very important thing about L4 is we have to remember that it is connection based, it is not message based. So that means it cannot read the message. Okay, so it cannot really go into the message contents, the HTTP headers, and take some decision based on that. For example, the like here, if you remember, we were discussing that there are some kind of a routing checkpoints are there. It discusses whether it assesses whether it goes to the slash profile or it goes to the slash recommendation. If it goes to the slash profile, this kind of decisions cannot be taken by the L4 load balancer, because it only have access to this few things like the source IP, destination IP, source port, and the destination port. Understood? So now let's take a example, and I will just write this statement so that um, it gets into your mind real quick. So um, like it is always a connection based, not message based. Okay, so let's try to see in high level what happens with the L4 load balancer and what are the main basic components there. So suppose from your mobile application you are trying to reach the Google server. Okay, so this is a Google backend server, and Google have a very famous L4 load balancing mechanism that is being known as the maglev. You can further read up to it. We were not taking the discussion of the maglev into the scope, but we will just go around the basic load balancer and the backend server, how the interaction works. So if you remember regarding the TLS, okay, from our previous video, so what would happen over here is at first, once it goes to the L4 load balancer, this five elements will be extracted. So these five elements, they have a nice name for it, like while dealing with in the L4 load balancer, it is being known as the five tuple. Okay, so this five tuple is kind of being persistent around the connection, and why it is necessary we will come to know about this in some time. Okay, so after this request comes to L4, what it does is it sends the SYN again. Like if it is looking a little foreign to you, this is what exactly happened during our TCP. So then it sends back the acknowledgement. Just bear with me, the next part will make complete sense if you don't even understand the TLS. So here what happens is at this stage the TLS connection, what we see, okay, here after this SYN SEK is being sent, the TLS connection is being established here. Okay, so TLS handshake happens. So then what would happen is, like, our client will start sending the data based on the source IP, this five tuples, destination IP, source port, destination port, and protocol. Based on this five tuple, what would happen is, like, the data will then keep on getting forwarded from here. So what L4 load balancer will try to see is, okay, that I understand that the request is coming from a given client IP. So suppose there is a client IP is like this dot 0 dot 100. Okay, and then it finds that most suitable destination server. Okay, so it finds that the most suitable destination server is suppose 10.10.1.50. Okay, let's include the port number as well. So it forwards it to here. All right, so this is a very on a very high level, this is a very basic mechanism of L4 load balancer. Now let me ask you one question. If we are able to understand that, probably then we understand the L4 load balancer completely. So the question that I want to pose to you is, can a L4 load balancer enforce rate limiting based on HTTP auth header? So just take a moment of pause and try to answer this question, that whether uh, like that whether a L4 load balancer can enforce the rate limiting based on the HTTP auth header. If your answer is absolutely not, it's a big no, then probably you grasp the concept correctly. So why it is a no? So understand, L4 load balancer operates on TCP streams without payload inspection. So for by L4 there is no payload or HTTP header inspection. Okay, so this is a very important part. It only happens based on this, the routing only happens based on the 5 tuple, and in case it has to take any internal decisions like this destination port is not healthy, so let's not forward it to that. So uh, it only happens based on those decision points. And also the important point is the auth header that we are talking about over here. Auth header is always it's a L7 stuff. Okay, so auth header has nothing to do with this 5 tuples that we talked about there, right? So rate limiting can be done. Now the complete answer would be something like this, like the rate limiting can be done, but it is based on that 5 tuples. Okay, like based on mostly it is done on the source IP address. So is the source IP address is like coming from some XYZ again and again in a stipulated time window, then probably we can enforce rate limiting on that. Okay, so in this case the actual alternative is, so for this case the actual alternate is L7 we use L7 load balancer. So one of the very popular usage outside this, like Facebook, Meta, or the in the data centers of Google, very practical use cases like the multiplayer gaming. Okay, so suppose there is a gaming company which is running a real-time multiplayer game. The game clients have to send fast and the frequent updates, and they do it using UDP. Okay, so UDP is again we covered in detail, and here every milliseconds counts. There is no time to parse the messages or the inspect the content. Okay, and we need to route the packets as quickly as possible to the right game server instance. So in that case the L4 load balancer is useful, and also like this is the like way more faster than L7. And why, we will just discuss this thing in detail, like why it is way more faster than L7. So when the reliability is secondary and the speed is the primary, we always go with the L4 load balancer. Like as I said, the multiplayer gaming is the option, and whenever we have to do any kind of routing based on the source IP, or there are out of these 5 tuples, in that case also L4 should be the first choice. So now let's do deep dive into the L7 load balancer. The first thing first, it works on the application layer that we understood, right? So when we say application layer, that means it is a like HTTP or HTTPS aware. So anything that is inside our HTTP header or even in the messages, all these things can be inspected by this L7 load balancer, and based on that we could do our own routing. So the example that we took earlier for the Netflix, let's took the same thing. Okay, so suppose from here login requests or some sort of a load requests come. Okay, so suppose slash API slash user slash load init, like the initial page will be loaded. So what are the things that will be passed over there is like there will be a JWT token, that will also go here, and that JWT token will be then used over here for the subsequent request that will come. So the first thing first, what happens is it does the TLS termination. So here the TLS termination happens. Again, like if you have any doubt on TLS termination, please refer to the previous video. But on a very high level, TLS termination means like from where the main TLS connection is being established into the subsequent layers. Okay, so here the TLS termination, that is the first thing that happens between this load balancer and the Netflix app. So the identity and everything are being checked among the servers, and after that what happens is like it validates the JWT token. So after this first step, the JWT token validation happens. So it is like validate JWT request that goes, and the response that comes is like the token valid. Okay, and after getting the token valid response, uh, there one of the interesting thing happens is like application of the routing rules. So here if you see this particular case, like the routing rules are evaluated, and we will just do a little bit of more deep dive how this routing rules actually looks like. So just stay with me for here. So the routing rules are evaluated here, and after the routing rules are evaluated, suppose the load init is coming from the, like it has two services calls. One is for user profile and the recommendation. So what happens is it routes it to the user profile, the first one, and the second one it routes it to the our recommendation service. So this is from the request side. These are the things that happens. So from the load balancer now, the, after this token validation request, so there is a like a slash user profile and slash recommendation. So just to clear few things, probably the load init, it has these two calls inside which load balancer can understand, and it routes these two things. Okay, and after that what happens is once both of these responses come, like from this level, also from this level, once this responses comes, then the aggregation of the responses happens. Okay, so at this level the main aggregation happens, and after this aggregation the combined response is being sent back to the client application. So what are the basic features that we did over here? So if you see, it was able to do the JWT validation, like here when the token, the bearer token that has been sent, it also does the path routing, and also if required it can do the rate limiting. It can inspect like how many how many requests that are coming from that single user or the single application IPs, and then also if required it can do some kind of a request transformation also. Suppose I do not want some information to be shown to the to my backend servers, so I can always put those kind of request transformation over here. And of course one more thing I forgot, that is the TLS termination. That is one of the must, right? Like when while establishing the main connection. So it validates the public key, private key, all the exchanges that are required during the transport layer security connection establishment. Load balancer does all of these things. So the bottom line is this routing to the most healthy instance is just one of a thing. So what load balancer does is like in a broader level, when we just see as a real world component, that it checks which one is the healthy endpoint, healthy machine rather, healthy machine in backend, and route it to that. So those health checks are also part of this. So what it will keep on doing is, before forwarding to this user profile to here, it will just see that if user profile service, suppose it has 3 instances. So based on multiple algorithm like round robin algorithm or some of the health check, okay, it determine which is the best instance. Okay, so that is one of the decision point that it takes at this, like which is the best instance I can forward it to. So based on that, we forward it to the maybe the user profile or the recommendation service based on all these details. Okay, so this is on a very high level what load balancer does. Now as we were discussing that we will also look up to how the routing rules are being done. Okay, so routing rules some way looks like this. So just just inspect this. So using these routing rules that are being put into some kind of a configuration over here, it tells that look, if the path is API slash users, you send it to the cluster of the user service, and then user service ingress probably take care that which one is the most healthiest instance of that, and returns the particular and routes the request to the particular one. And we can put timeouts and other stuff. Also, you see there are things like recommendations. So recommendation says that there will be like send it across to the premium recommendation service, and what is the number of retries that we will be putting. So this is what the load balancer configuration looks like. And one of the homework that we will put to you is create your own load balancer. And what you do is using Postman, you can like send concurrent request and route it to correct instance. So again, like you just like this can be a very useful POC to understand how load balancer works. So you can create your own load balancer, like as we discussed over here. We can just put a load balancer. You can write your own program and just put up three instances of the same application. You can it totally based on what tech stack you are using. So you can create like same endpoint for, sorry, the same app, three local endpoint, and using the load balancer, maybe you apply their round robin. Maybe you apply round robin there and just keep on seeing how exactly it is being routed, and you will learn done lot of things if you just do this small homework or POC that we are talking about. Now, before we close off our discussion, let's discuss some of the differences between the L4 and the L7. This is a very important thing to understand because in in real life it will be very useful for you. Okay, what is the difference between the L4 and the L7 on high level? So L7, just understand this thing, it does. So L7 does a very important thing that is called TLS termination. And if you remember from previous video, TLS termination has a very high CPU, or let me write in this way, a resource intensive. It is a high resource intensive operation. Okay. So what happens there is, like there is a, for example, in the CPU there is a high overhead due to the TLS handshake, and in the memory also there is a high overhead because the buffer, and it has to buffer the entire HTTP request for parsing. So because we have to read it, so we have to parse the whole request, right? So CPU is basically for the TLS, for the TLS handshake, the like there is a encrypt decrypt goes on, right? So this takes a lot of CPU, and for buffering the memory is being taken, and of course the latency is there because there is a additional processing time. Because of all this thing, there is a additional processing time that is being taken, and resource usage is like almost like there is a 5x more resource usage happen than L4. Okay. So L7 is like very rich application features at the cost of performance. So performance is a problem, but it gives you like rich features at cost of performance. Just understand this thing very deeply. Now, when we get any kind of issues like the real life issues, suppose my L7 is returning suppose L7 is returning something like a 504 error. Okay, so in this case, what are the possibilities? Okay, so 504 error is nothing but it is gateway timeout. Gateway timeout is mostly deals with the backend. Like suppose the database queries are taking too long, that is why the timeout is happening, or the external API dependencies are there, some resource exhaustion is there. Um, there even can be something like a DNS resolution problem or the packet loss. So when we are see that our L7 is returning this sort of error, what we generally should do is like look into the logs and uh, look for any long running operation. Then there can be things like network connectivity and DNS resolve issue. Okay, and plus there can be things like uh, the resource usages like the CPU and other memory usages. So when we are getting this sort of error of 504, because L7 has so many use cases that we talked about, so any of this thing might go wrong and it might be giving us the 504. So when we see this use cases, we cannot directly deduce that okay, this is for some long running process, or there are some network latency, or this is straight away DNS issue. So we have to go through the logs and inspect properly around this. Okay, so now let's consider a certain matrix to understand the difference between the L4 and the L7 more deeply manner. So the performance comparison is something like this. Like L4 definitely have a way more throughput, like it can process 10 million plus packets per second based on the configuration it has. So whereas L7 can also goes to close to million, but it depends, like there are some other factors will come there as well. So what is the latency of the processing? The latency of processing is less than 1 millisecond, but over here for the L7 it is like it might go up to the 10 millisecond. For the CPU usage, it is pretty low, but you understood, right? For the TLS handshake, the CPU usage can go up to the 70% also. The memory usage also is minimal, but here we have to do the whole request buffering, so the memory usage might skyrocket here. And the feature richness is like L4 is not that feature rich because it only does this IP based routing, whereas L7 does content based routing. Plus both of them can keep on checking the health point, keep on probing the health points, health check endpoints, and route the traffic based on that. And one important thing is it L4 supports any TCP or UDP, but here L7 supports HTTP 1 to gRPC and the WebSocket, mostly the TCP connections. Okay, so this is again one of the most differentiating factor. If we have to deal with the UDP traffic, like we had in case here, the for this multiplier gaming, we have to use L4 because L7 doesn't really support UDP. So now that L4 and L7 proxies we already discussed, so we understood that there is a certain level of overhead like there is a certain level of overhead associated with it, because the proxy decrypts and the re-encrypts the traffic in case of the L7 and route it. But the thing is that in the microservice architecture, this trade-off is this trade-off of latency and high memory usage of L7 is completely acceptable, because in microservice architecture it gives you like so many things. For example, based on this we get the routing flexibility, and then we get like a lot of observability as well, like what is the main request that is coming. If we only use L4, that doesn't even inspect the payload, so we don't even know what is coming through. And also we can based on this we can put additional additional security. So L7 proxies also enable like zero code changes for the features, like when we want to gRPC transcoding, which is a little bit advanced concept you can ignore, but in case we have a REST endpoint and we want to transcode it into the gRPC. Okay, so these are also one of the very great use cases of L7. And also there are things like A/B testing. I'm not going into all those details because then like the length of the video will probably elongate a more. A/B testing, there is something called traffic shadowing. You can study around these things and you will get a great idea that why L7 is like used across every single scaled up application. Okay, so be it Netflix, be it Uber, be it like Lyft, AWS, Google, any product house, any cloud house, every places we see that the L7 provides the application intelligence at the cost of performance overhead. Okay, but it is ideal for microservice architecture where the routing flexibility and the observability are the critical. So I think now by covering all these things, you get the complete idea of what reverse proxy is, what forward proxy is, and among the reverse and forward proxy, like what exactly is the load balancers are, and among load balancer the difference between the L7 L4, and why L7 is like dominating the industry for all the decisions or for all the routings that we are doing. So that's the video, guys. In case you have any question, please put in the comments. I will try my level best to answer that. I will back with my next set of videos. Till then, stay awesome. Bye.